Hey guys, today we are going to take a look at an example Centroid problem that I created. As you know, in Principles of Engineering we've been talking about how to calculate the center of mass of a 2D shape, also known as a centroid. So hopefully this example problem is helpful to you in identifying the steps that we need to take each time we solve one of these problems. So let's take a look at what we've got. Alright, so we've got a square and a triangle here, kind of looks like a one-eared cat. So I've got a list of steps that I've given you guys before that we're going to use as a reference here to set this problem up. So the first step says identify the shapes. So right off the bat we can see in this problem that we've got a triangle on top here and a square on bottom. So I'm going to call this shape 1 and I'm going to call this shape 2. It's worth mentioning that what I'm using here is the additive method, where we are using two shapes and adding their areas together. We talked about the subtractive method the other day in class, so if you weren't here, make sure you go back and look at the recording from Monday. Okay, so we've identified the shapes. The next step is to calculate their areas. Before we do that, we need to make sure we understand the dimensions of each shape. So our rectangle here has a height of 6 units, or 6 inches, and it's got a width of 5.5 inches. Our triangle has a base of, I'm going to call that 3 inches. I missed the line there, but we're going to call it 3 inches. And the height of the triangle is also 3 inches. Okay, so the next step is to calculate our areas. So I'm going to write A1 and A2. So our first shape is a triangle, and the area of a triangle is 1/2 base times height. The area of a square is base times height. So for our triangle, that's going to be 1/2 of 3 times 3. 3 times 3 is 9. Half of 9 is 4.5. So that is the area of shape 1. Our square has a shape, a base of 5.5. So 5.5 times 6. So 5.5 times 6 is 33. Okay, so we have done step 1 and step 2. The next step is to calculate the center of mass for each shape. So I'm going to write x1, y1, and x2 and y2. Now, this notation here denotes the center of mass that we've used in class up until this point. For a triangle, to calculate the center of mass, we take the base divided by 3, and we take the height divided by 3. For a rectangle, the equation that we use is base divided by 2, and for the height, it's height divided by 2. So the center of mass for our triangle is going to be 1 and 1, because the x-coordinate that we have is 3 inches, and the y height that we have is 3 inches. Now, these are local coordinates, and we will have to take care of that in a moment, but I'll come back to that in a second. For our rectangle, the height, 6 divided by 2, our centroid is at 3. For our x, or our base, that's going to be 5.5 divided by 2, which is 2 3/4, or 2.75. So our coordinates here for our centroids for the local shapes are 1, 1, and 2.75, and 3. So we've done step 1, identify the shapes. Step 2, calculate their areas. Step 3, calculate the center of mass for each shape. And then it says convert the centroid coordinates if they are not located at the origin. Now, our rectangle is sitting on the origin. We always assume that our origin is down here in this bottom left corner. So this is our 0, 0. So our coordinates for the rectangle are okay. The coordinates for our triangle are not. When we calculate the centroid of a triangle, we actually are assuming that our triangle is oriented with the right angle side on the origin. So the center of mass is actually somewhere in here. But our triangle that we just drew is actually flipped around. So we're going to have to do two things. Number one, we're going to have to add this vertical height that is sitting below the triangle, and then we're going to have to flip around the x-coordinate to reflect the direction that our triangle is pointed. So let's fix our y-coordinate first. This is the centroid coordinate for our y direction. It's pretty easy to fix. So if we look below the triangle, we see that it's sitting on top of the rectangle. So all we need to do to fix the y direction is just add the vertical height of the rectangle to the coordinate for our centroid. So it's got a height of 6 inches, so that means that the converted coordinate in the y direction is going to be 7, 6 plus 1. To fix our our x coordinate, right now it's 1. Our triangle has a base length of 3. So right now we've got this component, but we actually need to have the other part of that, because when our triangle is flipped around, this is actually on the right side instead of the left over here. So how do we fix that? Well, we just subtract that center of mass number from the overall length, which is 3. So 3 minus 2 gives us, 3 minus 1 gives us the proper coordinate in the right reference frame. So that is 2. But we also need to fix this, because right now our triangle starts in the middle of this shape. So we need to take half of, actually we said 5, so we said this is 3 inches, so we need to subtract 3 from 5.5 to figure out how far off of our origin line, our y-axis here, this actually is. So 5.5 minus 3 is 2.5. So that is how far off this is. So this length right here is 2.5, and then we need to add 2 to that to get us to our actual starting x position for the centroid. So that would be 5.5. So that is the converted coordinate for the triangle. So now we're going to use these two numbers to perform the rest of the operations for this example. So it says complete the tables and calculate the centroids. Okay, so the first table that we're going to look at here is the x, where it says the center of mass here. That is going to be the coordinate for the center of mass for shape 1, which we had to be 5.5. For shape 2, that's our rectangle. Our x coordinate was 2.75. The area of shape 1, we calculated that to be 4.5. The area of shape 2, we got that to be 33. Now, this right here says xi times ai. And all we're going to do is just multiply these two numbers together and these two numbers together. So 5.5 times 4.5 is 24.75. And 2.75 times 33 is 90.75. The next thing we need to do is to take care of this guy right here. This is Greek notation. It says sigma xi times ai. Now remember, the Greek letter sigma just means sum. So when we're looking at this, all we need to do is take these two numbers and add them together down here. So 24.75 plus 90.75 is 115.5. Whoops. Whoops. 115.5. Okay. So now I'm going to do the same thing that I just did, but with my y information now. So the y center of mass for shape 1 we had as 7. For shape 2 we had 3. I'm going to use the same areas because it's the same shapes. So for shape 1 it was 4.5. For shape 2 it's 33. And then I'm going to multiply these two together just like I did before to calculate yi times ai. 7 times 4.5 is 31.5. And 3 times 33 is 99. Now just like I did before, I'm going to take those numbers and add them up to get the sigma yi times ai. So 99 plus 31.5 is 130.5. Now I know that at this point it feels like we're just doing a bunch of number crunching, and we are. But we're going to need these numbers because we have two formulas that we're using here. These are the complex shape centroid equations. So on top we have sigma xi times ai divided by sigma ai. And I'm going to put a parenthesis around this, and I'll explain that in a second. I'm going to do the same thing for y. This is sigma yi times ai divided by sigma ai. So what do these things mean? Well, this is the center of mass for each individual shape times that shape's area, and then the sum of both of those. That's what we calculated right here. So for our x, I'm just going to plug that number in. That's 115.5. Okay, well, what's this bottom number? What is sigma ai? Well, sigma means sum, and ai means area of each shape. So sigma ai then means the sum of the areas. So the sum of the areas is going to be 4.5 plus 33, because those were the areas that we got for each of the shapes alone. So I'll write that number up here. Sigma ai is equal to 37.5. So taking that number and plugging that in here, that's going to be 115.5 divided by 37.5. And I get 3.08. And that is the x coordinate of our centroid. Now I'm going to do the exact same thing down here for the y. Sigma yiai is 130.5, and the sigma ai is the same because it's the same, so that's 37.5. So if I take those numbers, 130.5, and I divide 37.5, I get 3.48 as my coordinate for the y centroid. Now that makes sense because we have this triangle on top in the y direction, so the center of mass should be closer to the top than it is to the bottom. So hopefully this was a helpful exercise for you as we are getting more practice with centroids. If you need anything from me, please reach out. Hope you have a good rest of the day.